Next, axiomatic approach of probability. Let A be any event defined on sample space O of a random experiment. Therefore, P of A is the probability of event A defined on any real valued function on O. So there are three exams. Exam first, P of A greater equal 0. Exam second, P of sample space O is equal to 1. Exam third, P of union of I running from 1 to n, which is equal to summation of I is equal to summation of I running from 1 to n. So we discuss some theorem on probability, only statement, not proof. Theorem 1. For any event A defined on Ohm 0 less equal P of A less equal 1. Theorem 2. P of A is equal to 0. P of phi is equal to 0, where phi is an impossible event. Theorem 3. For any event A defined on sample space Ohm, P of A complement, which is equal to P1 minus P of A. This this statement of theorem is used for solving the example. Theorem 4. If A and B are two events defined on sample space Ohm such that A is subset of B, then P of A less equal P of B. Next, last theorem, theorem 5, addition theorem of probability. If A and B are two events defined on sample space Ohm, then P of A union B is equal to P of A plus P of B minus P of A intersection B. This statement is also used to solve the example. Remark. If A and B are two events defined on sample space Ohm, then first condition, P of A intersection B dash is equal to P of A minus P of A intersection B. Second, P of A dash intersection B is equal to P of A minus P of A intersection B. Now we solve the example. Example first, let A and B are any two events defined on the sample space Ohm. If P of A is equal to 0.6, P of B is equal to 0.7 and P of A intersection B is equal to 0.4, obtain P of A union B, P of A complement intersection B, P of A intersection B complement and P of A complement intersection B complement. So first we solve. First, given that P of A is equal to 0.6, P of B is equal to 0.7, P of A intersection B is equal to 0.4. So first we obtain P of A intersection B. Statement of theorem 5 is what? P of A union B is equal to P of A plus P of B minus P of A intersection B. So value of P of A is 0.6 plus P of B is 0.7 minus 0.4. Then addition and subtraction we use 0.9. Next we find second condition is second, P of A complement intersection B. We seen in remark, P of A complement intersection B is equal to P of B minus P of A intersection B. P of B is what? P of B is 0.7 minus P of A intersection B is 0.4, which is used 0.3. Third is the P of A intersection B complement, which is equal to P of A minus P of A intersection B. P of A is 0.6 and P of A intersection B is 0.4, which is equal to 0.2. Next is the fourth condition, P of A complement intersection B complement, which is equal to, by De Morgan's law, P of A union B complement. Then P of A union, we see that P of A complement is equal to what? 1 minus P of A. So here P of A union B complement is equal to 1 minus P of A union B, which is equal to 1 minus P of A union B, what is 0.9, which is equal to 0.1. Now next example, a card. Next example, a card is drawn at random from a well shuffled pack of cards. What is the probability that it is a diamond or a jack? So we find out what is the probability it is a diamond or jack. So there are two events. Event 1, event A is getting a diamond card, getting a diamond card, and event B is getting a jack card, and we have to obtain A intersection B is what? Diamond and jack card. So P of A is equal to what? M by N. म्हणजे डायमंड कार्ड किती इथं? P of A is equal to M by N, which is equal to 13 by 52, and P of B is equal to getting a jack card. Jack cards are 4 by 52, and P of A intersection B is equal to 1 by 52. P of A is equal to what आलं? काय आलं इथं? 13 by 52. तर प्लेइंग कार्डमध्ये डायमंड कार्ड किती असतात? डायमंड कार्ड असतं, डायमंड कार्डचा एक सूट असतो, त्याच्यामध्ये किती कार्ड असतात? 13. म्हणून इथं काय घेतलं आहे? 13 by 52. अँड गेटिंग अ जॅक कार्ड. जॅक कार्ड प्रत्येकी 4 सूट असतात, 4 सूटमध्ये म्हणजे प्रत्येक सूटमध्ये जॅक कार्ड असतो, म्हणजे जॅक कार्ड किती झाले? 4. अँड P of A intersection D is 1 by 52. And we have to calculate P of getting a diamond or jack card, which is equal to P of A union B, which is equal to P of A plus P of B minus P of A intersection B, which is equal to 13 by 52 plus 4 by 52 minus 1 by 52, which is equal to 17 by 52 minus 1 by 52, which is equal to 16 by 52, which is equal to 4 by 30. So our chapter is over, and today we stop here.